That brings us to big idea number 3, gene expression, gene regulation, and signal transmission. Let's take a look. So, what we're dealing with, let's review briefly the central dogma of biology. DNA stores the information, RNA moves that information, and proteins help to express that trait. Okay? Gene expression is basically the concepts of transcription and translation together, and that's going to be our focus. Mother Nature has the ability to control this process at a variety of steps. In the DNA, how that DNA is stored. In the RNA, how that RNA transcript is then expressed as a protein. And once we've produced a protein, we can use allosteric control to affect the shape and configuration of that protein, and so thereby having multiple steps of control all along the way. Our first investigation here is going to be the Operon model. First discovered back in 1961 in the E. coli bacteria. This was our first true step-by-step understanding of exactly how gene expression was controlled. Okay, here is Jacob and Monod. I'm sure I'm hacking the pronunciation of those names. But here's our operon model. An operon consists of an operator, a promoter, and the genes they control. So here's our promoter site, typically the Tata box. Here is our operator, basically the light switch of this operon, if you will, and the genes that they control behind them, however many genes that happens to be. So we can have either positive or negative control. Positive control allows for genes to be expressed when there's something there. Negative control expresses that gene when there isn't that something there. Okay, so we can begin a process if materials show up, or we can turn off a process if there's not enough of something. The lac operon was the first one that was figured out. Here we've got 3 genes coding for enzymes to digest lactose in the E. coli bacteria. And a single promoter site serves all 3 of those genes. So here's lactose. This is the typical milk sugar. Now, there are a number of videos throughout this Prezi. For presentation purposes, I'm going to let you find those in the Prezi. You're welcome to find that link on my website and watch those videos, but for time's sake, we're not going to watch them here. So here's a lac operon. So here's our regulatory gene. Okay, this regulatory gene is going to produce the active repressor. We have our promoter site, which is going to attract the RNA polymerase, and our operator, the light switch. When engaged, the operator prevents the RNA polymerase from moving down the remainder of the DNA strand here. And when in place, that active repressor turns the operator off and no RNA is being made.